Hey everyone, happy Monday. How's it going? Welcome to February 2020. Can't believe we made it all the way. Um, I was talking to Ian O'Neill on Twitter, and he was saying this just felt like the longest January he'd ever experienced. And yeah, it has been quite a January so far. And now, February. Like, let's just keep an eye on February. If it's longer than normal this year, then we could know that something weird is going on. So just watch out for any weird leaps. All right. So for those of you who are wondering what it is that you have stumbled into, this is of course my Monday open space, totally wide open, no plan, no agenda, no schedule. This is where I do my question and answer show live, just so we can just really close the loop on all of the cool stuff that's happening. Like right now, if you want to sort of get more information or you want to know my thinking about it, then this is the place to do it. So let's see, just a little bit of housekeeping, of course. We have scheduled the premiere for the next episode, which is going to be on Tuesday at noon. Look at us adhering to a regular schedule. So that's going to be all about abort systems. That's happening on Tuesday. I've written the episode for an episode on Solar Orbiter, and the plan is to release that on a week tomorrow, which hopefully the mission will have launched. And then when I say that the spacecraft launched, it is correct. But if not, then then we'll have to edit the video. And then I'm going to probably do a video very quickly on this amazing image of the sun that was taken from the new solar telescope that was I guess saw first light. And I'm actually pretty fascinated just like how they took the picture. What does it take to take a picture of the sun at that kind of resolution? So I'm going to be doing a video on that, and that'll probably be the one that goes on Friday, but it's not even started yet, so we'll see. Could be tight. All right. Apart from that, we've got a couple of guests coming up. We've got Phil Metzger again is still coming up towards the end of the month. I've got Susanna Kohler from Astrobites is going to be coming up, and I put out a bunch of requests as well. So stay tuned for those episodes of Open Space coming up. And then just to give you just a 3 weeks warning, I'm going to be going on a trip with my son at the end of February. And we're going to Japan, which, I hope the coronavirus has settled down by then, so we don't have any problems with flight. But it's been, anyway, it's a trip we've been planning for a long time, so I'm looking forward to doing that. So I won't be available for a bunch of episodes end of February, early March. So, all right, hopefully this is this is time to move forward. So, question from Sciolist. Why did we stop launching animals in space? Animals are still launched into space. Whoever said that they weren't? Didn't you hear that the Israeli mission that crash landed on the moon was carrying a bunch of water bears on board? There are regularly animals sent up to the International Space Station: mice, spiders, smaller animals. So animals are regularly go up to space. Nothing big anymore. They don't send cats, chimpanzees, things like that. And that's because, the early tests with animals on board going up to the International Space Station was just like, or into space in general, was just like, will going to space make a human body explode? Right? They didn't know what would happen. And so they tested it with cats and dogs and chimpanzees and sent them to space. And then they did medical tests on them. We now know quite precisely what happens to human beings and animals when they go to space. Not good, but not explode bad. So at this point, there's no real need. Now, obviously, there are other experiments that are done, especially in the fields of, like, say, trying to figure out gravity. You can imagine them sending Eventually I wouldn't be surprised if there's a chimpanzee sent to a rotating space station to try and help understand what the impacts are of lower gravity. It'll probably just be rats. Yeah, it wouldn't be anything larger. I mean, you'll learn a ton just from what happens with rats. Rats go and spend a couple of years in space. The rats have babies. The babies have babies. It all happens in artificial gravity at various levels, and we find out what's going on. So at this point, there's not a lot that's new to learn about sending animals to space. We'll see what happens, right? If when people go and settle Mars, will they take their animals with us? Would you want to be trapped in a enclosed space station with a cow? I don't know, a goat? So anyway, that's why. Dragon King. Do you think that faster than light travel is possible? No. I don't think it is. Just now, the laws of physics as we currently understand them say that faster than light travel isn't possible. Now there are these exceptions that people talk about. You can have a warp drive, an Alcubierre warp drive, where you warp space and time, and there are wormholes where you can proceed through one end of the wormhole and then it doesn't collapse and you come out the other side. And these require exotic forms of mass, negative mass, things like that to maybe make them work. And the reality is the only thing they've got going for them is that we really, really want them, because space is really big and taking thousands of years to even just go to the nearest star sucks. But just because we want something to be true doesn't mean that it is. So at this point, I don't feel like we will ever discover a way to move faster than the speed of light, which is fine, because you've got all of the speeds up to the speed of light to still enjoy. And of course, the wonderful thing about moving at relativistic speeds, as you're moving closer and closer to the speed of light, is that time changes for you, so that you could travel 10 billion light years in your lifetime. And that's kind of amazing. So, it's just going to be one of those limits that we're just going to have to work around, in my opinion. But who knows, right? I mean, we don't know what new technology will be discovered. It could very well be. So for now, it seems like it's impossible, but who knows? Kim Barron, article on Universe Today, talks about moving a geo satellite to the graveyard orbit. Why wouldn't they deorbit it when it can still maneuver? So when satellites are up at geosynchronous orbit, they are tens of thousands of kilometers above the Earth, and they're going in this geosynchronous orbit. And so for them to actually be able to get down and crash into the Earth, they would have to be able to deorbit themselves, and that's going to require more fuel than they have available to themselves. So unless they can do that, they're just going to go around and around the Earth. And so the bigger issue for them to do is to move it to a higher orbit, or a graveyard orbit, a place where they're not going to be able to interact with any other spacecraft, and then they can shut them down and they're just not a risk to the future. So none of these spacecraft up in geosynchronous orbit are equipped with any way to be able to crash themselves back into the Earth when they're done. It's only the low Earth orbit spacecraft that are actually that have a chance of being able to actually crash back into the Earth. But once you get above a few thousand kilometers, it's going to take a long time for these spacecraft to come back to Earth. Let's see. Brian Yuku, the U.S. House is proposing a bill to delay or reduce the emphasis of Artemis in favor of a Mars mission. Can you argue both sides of the debate why a moon mission is needed or not needed before Mars? Well, I mean, I'm not the best person to advocate for this, because I don't think that either one is the highest priority, personally. I think the highest priority is to develop some kind of artificial gravity in space, some kind of rotating space station where we can really start to understand what the implications of lower amounts of gravity are on the human body over long periods of time. That is what I think is currently the big unknown that we need to sort out, as well as methods of protection from radiation over long periods of time. And so if I was in charge of NASA, I would be focusing on a capabilities-driven plan, which is just to increase the ability to travel in space, to survive in space, to harvest resources in space for longer and longer and longer. And so if I'm not allowed to advocate for that, then I think that the moon makes more sense than Mars. The moon is closer. It is, if anything goes wrong, which it will, it's easier to just get up there and send more supplies and rescue people who are on the moon and just learn to, you kind of, I don't know, it's like debugging code, right? When you're programming and something breaks in your software, you have to debug it. And then you think you've solved the problem, and then you compile your code again, and then you find another bug, right? So it's like that, except human lives are at stake on the moon or on Mars. And so you could run out of one thing on Mars. Like, oh, we didn't bring enough potassium, and now everybody's going to get space scurvy. I don't know. I'm making this up. But the point is that then you've got to wait for the next time that that Mars and the Earth have a window that you can go on a home and transfer, and you can send more space scurvy medicine. And while the moon, it's a couple of days away. And so you can have a rocket ready to go that just is empty with, the stuff that the astronauts are going to need right now. And then the second there's enough of these things, you fill up the rocket and away it goes. And then you've learned a bunch of lessons about what it takes to live in space. And so I don't think we've just learned enough lessons about what it's going to take to live in space. Better to make those mistakes close to home than to make those mistakes far away from home. Mars would be so much cooler. I get it, right? Mars would be awesome to be able to walk around and be on the red planet and to look back and see the Earth and to know that you're on the most Earth-like place in the solar system and possibly the future home for millions of human beings. But it's years away. And if anything goes wrong, which it will, which it always does, then help is years away. So that's why I think going to the moon makes more sense. It's not about commercial reasons. It's not about business reasons. It's just about debugging living in space. DStonks333. Question, did you see the high-res photos of the sun, and what can we learn from all that? Did I ever? Wow. I mean, those pictures from the sun are absolutely incredible. And that's going to be Friday's video. So I don't know everything that we learned about it, but I will know by the time I've written the episode. But the short answer really is that the more we understand about the sun, the more that we can understand what its impact is on our local environment. Now it's starting to look like Earth will see a disruptive solar storm probably once every 25 years that will cause some impact. Like, think about the one that crashed the electrical system, caused a big problem in Quebec there was like an ice storm, and there was like a solar storm that happened back in Quebec several years ago and dropped a huge chunk of the power grid. And so we can see these kinds of events happen on a regular basis. So to be able to see the sun with that kind of resolution, to really understand what is the connection between the features, the magnetic environment on the sun, and the impact that we have here on Earth. That is the big mystery that needs to be solved when it comes to just being able to be out there and spend time in space, to get some advance notice when something is bubbling up from the sun that's going to cause problems here on Earth. We want to know. We want to know what the precursors are. What's going to tell us that, oh, look, you can see in about a week we're going to have bad space weather, so let's unplug connected systems for when the space weather happens. And we're not there yet. And so it still comes as a surprise every single time. And so I think that's where we need to get to. Madhu Badu, how do you refine metal in space? There's some pretty interesting research that's being done. In fact, Phil Metzger, who's going to be joining us in a couple of weeks, is one of the people working on this. And there's some great research that's coming out of Europe where they're able to bake Martian regolith get rid of all the volatiles, and they're just left with a pile of metal, of aluminum and other metals, and it's kind of amazing. So the exact techniques are still unknown, and again, back to the list of problems that need to be troubleshot, right? But there are some pretty cool ideas right now. Like, you grab a tiny asteroid, you enclose it entirely, you bake off all the volatiles, and you're left with, so you bake off all the water, all the free gases that you require, and then you're left with the rock that's very dry, and then you crush it up, and then you can use other techniques to try and turn it into metal. And you know, the moon is like, when you look at the surface of the moon, you're looking at aluminum and oxygen and silicon and oxygen and titanium and oxygen. Like, there's a lot of metal on the surface of the moon, and iron. So I definitely need to do I'll do a video on this at some point. Trey Harmon. Fraser, should we be concerned that SLS is using very old used engines? Are we unable to manufacture the RS-25 engines today? Would that really cost more than the current cost to do so? Thoughts? Yeah, they're going to do both. So when the Space Launch System, which is of course NASA's new big rocket, first launches, it's going to be launching with the RS-25 engines. These are the engines that were used on the space shuttle. When you think about the space shuttle, those three engines on the back of the orbiter, those are the RS-25s, and they're one of the fanciest engines, most efficient engines that humanity has ever created. They're considered to be the Ferrari of rocket engines, and a big reason was because they were reused, and so they were able to reuse these really fancy engines multiple times. With the Space Launch System, there's going to be 4 of them on the bottom of the rocket, and it's going to destroy them. So the first stage will launch, and then the first stage will crash into the ocean, and the rockets will be destroyed. The engines will be destroyed, which is really sad. And so the company that's building them, it's Aerojet Rocketdyne. They've got 16 of them or 20 left over from the original Space Shuttle series, and they're going to use those up first, and then they're going to start building new ones. And for as long as the Space Launch System flies and needs these RS-25 rockets, which each one will make you cry as you watch these beautiful rockets go. But come on, right? Come on. Starship, Falcon Heavy. We're not going to see Space Launch System really get to the point where it's using up a lot of brand new RS-25 rockets. Like, that's, now we're 6 years down the road, 8 years down the road. I just can't feel like this is going to be the way. A decade from now, the best launch platform that we have is the Space Launch System with these RS-25s. So, but right now, there are no other options. There is no other rocket system that is capable of launching the kinds of payloads that it will take to send humans back to the moon. The Falcon Heavy can't do it. The Starship doesn't exist, right? And so to place your hopes and dreams on a rocket that's going to be delivered by SpaceX is not a wise strategy. We've seen how this works in the past, where you wait for some knight in shining armor to deliver your future technology. It doesn't happen, right? So I think it makes all the sense in the world to keep applying the pressure with Space Launch System, to keep that rocket moving forward until a better option comes along. And then by all means, just scrap it and just push everything onto Starship, and away you go. A.V. Scott and Flower, could you interview someone from SpaceX about probable future plans to integrate spin gravity, or ask Tim to ask Elon? Oh, yeah, Tim has Elon Musk, Tim Dodd, Everyday Astronaut. They check quite a bit. They've got to be good friends. I don't think that SpaceX is necessarily the right people to talk to about that. There's some other people that are really interesting who are working on this, have done proposals for like the Nautilus X attachment to the International Space Station. So maybe I'll talk to someone like that about this. So good suggestion. James Cook, would CMEs or solar flares conceivably vitrify rock on Earth? I hope not. That sounds really awful if you've got a solar flare that's so bad. Or are you talking about like back in the beginning? Larry Beckham, we have leftover RS-25s. Yeah, they have 16. They have enough for 4 launches, I think. There's some other questions back there. I apologize. The moderators are throwing these in here. Bogdan Bradis, hey Fraser, when will the ISS project end and how? Will they crash it? Will they end it? Want to keep it in space to do more science? At this point, the International Space Station has been funded through till I think 2028, and then it's up to the various individual partnerships to decide if they want to continue funding it. Will they? I mean, in theory, when they're done, they will deorbit the spacecraft into the Pacific Ocean like they've done with so many other spacecraft. But that sounds crazy to me, that they will take this perfectly good space station that has cost hundreds of billions of dollars at this point and then just deorbit it because they can't keep spending several hundred million or billions of dollars to keep funding it. NASA just is in the process of developing Crew Dragon and Starliner, so 2 different systems, plus the work they're doing with the Dream Chaser to get cargo to and from the International Space Station. So I can't imagine that they will deorbit it that quickly. But if the Russians are broke and they pull out, then maybe the Americans will. Now, I don't think the space station will continue being the same sort of configuration that it has been for a long time. I mean, we're seeing that NASA announced that they're adding a commercial section to the International Space Station. So you could see it becoming more and more of a commercial operation instead of it being a pure science platform. And maybe that will be able to supply maybe even just tourists. So I think you've got to be open that the space station won't remain what we think it is today. But we will see what happens. But yeah, I can't imagine they'll crash it in 8 years. Don McLeod, people don't want to know. Don McLeod asks, when do you think we'll build a space elevator? I think we'll never build a space elevator. Never. And the reason is because there's 2 reasons, right? The first reason is that the reusable rockets are actually, at this point, it looks like they're going to be cheaper than a space elevator. Like if you just look at the price per pound, the Starship in its full configuration, full reusability, will actually be a cheaper cost per pound than sending payloads to space than on a space elevator. And then the second thing is that once we have significant infrastructure in space, and I'm talking like maybe in 50 years, there will be no need to send any cargo from the Earth to space. It just won't be required anymore. Everything that you're going to want, you're just going to get from space, from asteroids, from comets, from the surface of the moon, and then manufacture pretty much everything that you require. It's only going to be the people, the meat. And so you're not going to need to build this $1 trillion tether to space using technology that hasn't even been figured out. So I think for Earth, a space elevator will never be built. But, by all means, tell me I'm wrong. For going to, and Cody's Lab is saying Orbital Ring owns a space elevator. Orbital Ring has its problems of its own as well. So no, I just don't think that we will, that kind of infrastructure to go from the ground to space will stick around for very long. We will get to this point where you may want to go to space, right? But you won't need to carry necessarily a lot of stuff from one place to the other. But that's how I feel, and who knows what happens. Stephen Showalter, is Betelgeuse continuing to dim since you last covered it? What are some likely reasons for the dimming? Yeah, Betelgeuse is continuing to dim. The last time that I saw it, it was down to 1.6 magnitude. So it's almost the 3rd brightest star in Orion. If it gets to I think 1.66, it becomes the 3rd dimmest star, or 3rd brightest star in the constellation, which is kind of amazing. And it is continuing to dim. The dimming is slowing, but it is still happening. It's still within fairly understood variations. It's more than we've seen in modern memory, but it's not like, okay, this is it. This star is going to explode. It's just that it's, every now and then you have a 100-year flood. Every now and then you have a serious, significant dimming, and this is our moment. So no explanations beyond the usual, which is like crazy big convective cells, additional material blowing off of it, a larger, therefore dimmer. No, sorry, I'm trying to remember which way it goes. It goes smaller, dimmer. I forget which one it is. Anyway, it changes in size. And then, of course, it's got all of the potential debris that it's already blown off, and some of that could just be passing in front of the star right now, changing what we see. So there's a lot of things that could be impacting why it is getting dimmer. But I've asked a bunch of astronomers, like what's the number that you go, okay, this is weird? And I haven't been able to get a straight answer yet. HQ Cart, do black holes increase or decrease in volume the more stuff falls in? So in theory, now we don't know what the actual volume of a black hole is. A black hole has an event horizon, which is the region where nothing, not even light, can escape. And then somewhere inside this event horizon is the black hole itself, the singularity. And they call it the singularity because it is some finite amount of mass that is theoretically compressed to some infinitely small volume of space. It has an infinite density. So how big is, in terms of volume, how big is the infinitely small amount of space? It's infinitely small. And if it increases, it's not actually increasing in volume. It's just getting more dense, and it's still infinitely small. But of course, we don't know what actually a black hole is. Is it a singularity? Is it a little sphere that is held out by the outward pressure of some exotic object that we don't understand, or particle? We don't know. But we do know that the event horizon, which is that region, is sort of like the no turning back line when you fall into a black hole, that the size, essentially the volume that is enclosed by the event horizon, does expand as more mass falls in. So yes, the actual volume of the event horizon of a black hole expands as more material is falling into it. Larry Beckham, any news on the DarkSat, Starlink sat? Not news that you're going to find useful. So for people who don't know, of course, there is the Starlink launches. Now we're up to 240 Starlinks. But one of the previous batch was painted with some kind of darkening materials, although people were kind of vague on what they did, to try and make it less obvious in telescopes. And the problem is so far, it hasn't really changed in brightness. And Dave Dickinson did an article on Universe Today about this, talking about people trying to see it. And so far, it doesn't look like it's any dimmer than the rest of the Starlinks. But Starlink said this is what will be expected, because in the beginning, as the satellites are raising their orbits, they will use they'll be in a configuration that's more reflective until they get to their final configuration, and then they'll change the way the solar panel is facing so it's not as reflective, and then that's when we'll start to really see the impact. So we're still probably another 2 weeks from that second batch of Starlinks being in its final configuration, and then we'll be able to finally know. A bunch of people are saying they lost the stream. Did anyone not lose the stream? Yeah, some people are seeing the stream, so I guess you need to restart. I guess the people who don't know, you need to restart. All right, so I apologize to everybody who did. John Victor, would we detect a neutrino burst from Betelgeuse before seeing the supernova. I wonder how close the behind the light would be. Yeah, so if we did see a supernova, you would get a flash of neutrinos that would arrive just before the star itself exploded. And of course, a lot of people said, oh, are you saying that neutrinos go faster than the speed of light? No. The trick is that neutrinos are free to move through the material of the star. They're not blocked in any way, shape, or form. So as the star is falling in on itself, like close to the speed of light, 99% of the energy released in the supernova explosion are released in the form of neutrinos. And the neutrinos escape immediately. They pass right through the solar material like it's not even there, while the radiation piles up in this stellar material. And think about the way that the way radiation moves through the interior of the sun. It has to jump from atom to atom. And so you're going to have this delay. And so we would see the neutrinos first, and then we would see the light from the star, because the neutrinos are still moving slower than the speed of light, but they're moving like 99.99999, like only a little bit slower than the light itself. Slam RN. Do you think that astronomers will try to use legal action to stop the launch of the Starlink satellites? Would you stop it if you could? That's interesting. I think some astronomers will try to use legal action to stop the launch of Starlinks. Yeah, I think that's going to happen. I think and in fact, I've even heard some possible regulations that might have been sort of environmental protections that might have been walked over as the process of launching these satellites because they're so bright. So I think we're going to see that for sure. I think it will fail, but I think we're going to see that. Would I stop it if I could? See, and I keep saying this over and over again, which is that the value of Starlink depends on how it's used. So if Starlink is used for banks to make more money so they can trade and shave a few nanoseconds off their trades, then I'll be outraged that we've lost more of our skies. We've already got light pollution. We've already got airplanes. We've already got the moon and clouds. And now satellite trails? So if that's the purpose. But if what happens is that, again, regular human beings across the world who could not get internet in any way, shape, or form now do at a reasonable price that they can afford, then it's worth it, right? And who am I to stand and to say that they shouldn't, because I don't want to have to pull lines out of my astrophotography, which I do, right? Like people who've joined me on some of the live streams with the telescope, like, oh, we got a bunch of trails through our picture. I have to throw that one in the garbage, right? Like I have to do that. But, the annoyance of me throwing trails out, the longer time that needs to be spent on science for these big telescopes, it all depends on the benefit to humanity. And right now, the internet has a big benefit to humanity. And the traditional methods of getting internet to all of humanity has costs too. Think about the manufacturing costs of building cell phone towers. There's 5 million now, millions more. I've said this many times. So I think that there will be legal action. I don't know whether it will be successful, but I'm sure some people will take a crack at it. Just because like they were launched without any real conversation with the astronomical community. To SpaceX's credit, they're having these conversations now, but they should have had these conversations before and tried all kinds of experiments to figure this out, to minimize the impact on the skies. But they didn't. And so here we are. And so now people are going to apply legal pressure. And I don't think you can necessarily wait for them to make these changes on their own. They need to be pressured. And ideally, they'll have conversation, and if it goes to, and I think people are definitely going to be considering legal action. But for me, right, again, if if people got access to the internet and these things were just like bright laser beams that passed above the sky, I would still think it was worth it. As much as that would suck, having access to the internet is really important for humanity. So it all, like, we're all just going to have to find out how it all settles out. Erda Diero, do you have much light pollution where you live? This seems to get worse every year. Yeah, I've got some light pollution where I live. I live in a medium-sized city in Canada on Vancouver Island, so we don't have a lot of light pollution around us where we are, but we've got about 50,000 people here in our city, which is called Courtney on Vancouver Island. And so, but I can see the Milky Way from my backyard in like a really nice clear night. There's lots and lots of stars. And then if I go out of town, maybe 20 minutes, I can see the Milky Way really nicely. And then if I go an hour, then it's as dark as you can possibly hope for the skies. And I feel really fortunate to be able to have that kind of access to it. And like, I would definitely start with curbing light pollution. If getting access to our skies are important to us, we need to get rid of light pollution because it's a big problem right now. You look at these light pollution maps of like half of the eastern seaboard of the United States and like Europe, and there's no place they can go and not get away from these horrible lights that are shining up into the night. And we can fix this. So that's definitely where I would start. Brian Yuku, what was your favorite name finalist for Mars 2020? I like Promise. I forget let me see. Was it Vengeance? No, that's not it. Pestilence? No. All right. Let me see. I think Patience was the one that I liked. Let's see what they are. Oh, it's closed. What were the finalists? Vengeance? Pestilence? Yeah. Yeah, no, I think Patience was the one that I liked. Van Mill, come to Wyoming. I'll show you dark skies. Yeah, I mean, we've got dark skies here that are about like that, right? Where there isn't a city that, I can go into the backcountry of Vancouver Island. The problem is that you've probably got clearer skies than we do. We have rain. Rain and clouds and rain for most of the year. But in the wintertime, when the skies clear up and it's dark and there's been like a recent rain to clear out a lot of the mist in the air, it's phenomenal. But it's something like Australia. That's crazy skies. When my wife and I were traveling around in Australia, and I've never seen skies like that. Just unbelievable. So Romulus XC, what do you think about the House of Bill and NASA's postponing of the moon landing to 2028? So I don't know if I actually got to the end of that, but I think it's like however late the White House administration really pushed for 2024. NASA said, okay, fine, we can do 2024 if you help us get the funding. They didn't help them get the funding. Therefore, it makes sense to push back to 2028, which was kind of the plan anyway. So it doesn't matter, right? So what if it takes another 4 years to do this? I'm not really that concerned. Java Man, Fraser, have you ever been to Stellafane? If not, would you consider going? No, I've never been to Stellafane. Would I go? I don't know. Probably not. Where's the next? It's a conference, right? Where's the next one? (2020) Wisconsin, Springfield, Vermont. Yeah. Yeah, I don't travel to Vermont very often. Like, I'm sure if they invited me and wanted me to speak, and paid for my flight, I would do it. And paid a speaker fee, I would do it. But it's tough. Like when we travel, like it's hard. Like I know it's like, oh no, uh, YouTuber problems. But anyone who's done a lot of business travel, it's just wears on you. And so I try to say no to a lot of stuff that mean leaving my house. Um, just because, I mean, partly I don't want to increase my carbon footprint, and it's also just like you've got a couple of days of getting to whatever the event is, and then you've got some time that you spend there, and then many days to get back. And so John is saying that it's uh, Stellafane was remarkable this year. I highly recommend it. Yearly in Vermont, not too far from you. Well, I am in Canada, but I'm on the west coast of Canada, so I'm right by Seattle, and that so Seattle is close to me, but Vermont is not. Vermont is like 5,000 kilometers away from me. Um, so I'm doing. Looks like I'm going to be doing the keynote at the Royal Astronomical Society of Canada meeting, which is going to be in Vancouver in June. So if you're going to be in Vancouver, come join me. Um, and that's a nice trip, right? I just fly over to Vancouver. It's 20 minutes. I'll give my talk. I'll come back home. So, Lucid Moses, would you support anyone wanting the internet having to pay for 2 to 3 others that can't afford it instead of Starlink? I don't know whether that would be the price that it would cost to build a whole bunch of cell phone towers. So um, I don't think that, like, I think to get the rest of humanity onto the internet, I think we're looking at a 10, like an order of magnitude more expense to get traditional cell towers and underwater cables and digging tunnels to every corner of the earth to help people get onto the internet. It's going to be a huge environmental hit to be able to do that. I mean, cell phone towers, forget the number, they kill some order of millions of birds every year because birds run into them. That sucks, right? Um, they're microwave transmitters, they produce heat around them. So that's not good, right? Um, so so you know, I don't know what to do. Donovan Gustafson, are winters bad on Vancouver Island? No, they're well. It depends who you ask. Ask my wife. They're terrible. but but for me, they're fine. We live. It's described. We live on the in the Florida of Canada. So most winters we don't even get snow. It just rains and it rains and it rains and it rains. But we don't. It doesn't get that cold. We'll get a few days of snow usually, and we'll get um, some freezing temperatures for a couple of days. But it's nothing like every other part of Canada where we live. Melts 1515. Are you losing hair exponentially? I don't know. Probably. Although I shave my head as best I can. So it's, at a certain point, I think we all people who are losing their hair, they reach this point and then you just shave your head and you just go full Picard and there's no turning back. So at a certain point, you no longer care. Sebastian Guriape, could we use the sun as a gravitational lens like black holes? Yeah, we could. If you go to about 1,000 astronomical units away from the sun, so about 1,000 times farther than the distance from the Earth to the sun, then the sun acts like a gravitational, like a lens, like a perfect lens in the sky. And you could use that to, say, study objects on other planets. You could observe right out to the edge of the observable universe. There's all kinds of amazing stuff that you could do. The trick is getting your spacecraft out to 1,000 astronomical units away from the sun. And we get this beautiful natural version of this with regular natural gravitational lenses. When you look at these galaxy clusters that are perfectly lined up, allowing you to see, like normally Hubble can see out to, say, I forget what it is, like about 1 billion years after the Big Bang. But if things are perfectly lined up, it can see all the way like another to 500 million years after the Big Bang. It's pretty impressive what gravity, dark matter, we don't know what it is, but we can use it as a telescope lens, which is pretty incredible. Let's see. Makesh Kalani, what if the Earth starts rotating at double its current speed? I don't know. So right now the Earth rotates at about 1,000 kilometers per hour at the equator. And so if the Earth rotated at double its speed, the Earth would flatten out. A day would be half as long. So a day would be 12 hours long. The planet would flatten out a little bit more, so that the distance across the equator would be more than the distance from the pole to the pole. You would probably get more ferocious storms, because the speed of the planet's rotation has an impact on the strength of the storms that and the in the northern and southern hemisphere. You would weigh a little bit less. I think right now you weigh some fraction of a pound less when you're at the equator than when you're at the poles, because essentially you're experiencing an outward force as the Earth is trying to spin you off of itself. And so if the rate doubled, then you would weigh less while you're at the equator. So I'm sure there are all kinds of other more detailed things that might be happening, but that's the big stuff. Larry Beckham, do you think that SpaceX will launch starships suborbital from Port LA to Boca Chica and the Cape? Well, I mean, if SpaceX can figure out how to launch these things suborbitally, you'll in theory see starships launch suborbitally from many big cities around the world. You'll see them from Los Angeles and New York and Sydney and Europe and all kinds of places, right? In the short term, I can totally imagine them shuffling starships from launch site to launch site, depending on who needs more boosters or starships or what have you. Larry Beckham, was the Earth's rotation faster in the olden days? Yeah, the rotation speed of the Earth is slowing down, and the moon is getting farther away from us. And so in the past, Earth turned faster and the moon was closer. What's kind of amazing, and this is like, people think it's this very smooth transition from the moon being really close to slowly moving away, but apparently it actually did a ton of its motion really quickly, and then the speed has slowed down. There was a paper that I saw where they were talking about sort of what the rate was, and it was actually pretty dramatic. And so we always think that if we went back, to the dinosaur time, then the moon would look way bigger, but actually the moon wouldn't look that much bigger. It's only if you went back to, say, 10 million years after the moon had formed, then the moon would look really big. But I don't have the exact numbers in my head. I apologize. Dan Miller, does the Fermi Paradox apply to all forms of complex life, such as various animals, wildlife, or does it specifically apply to human level intelligence or greater? Well, yeah, I mean, the Fermi Paradox says that the universe is big and old, and life should be everywhere, and therefore, and life on Earth turned into intelligent civilizations, and as soon as intelligent civilizations form, they should be capable of settling the entire galaxy. So animals, in highly intelligent, complex animals, would be an indication that it's on the pathway to more advanced forms of intelligence. I mean, advanced intelligence like human beings have only happened once that we know of, but there are lots of other animals that are pretty close. When you look at cetaceans, look at octopuses, look at parrots, look at pigs, look at the rest of the great apes, it seems feasible that given enough time, given enough time, some other animal will form a level of intelligence to be able to tool use and spacecraft and internet and all that kind of stuff, right? And so if we see, and so there's these ideas of the great filters, and the one great filter is this idea of multicellular organism. And so if we look around the whole universe and we only see single-celled organisms, then the thing that's really interesting that happened here on Earth is we went from a single-celled organism to a multicelled organism. And so a nematode worm as a multicellular organism is an incredibly more complicated sort of entity than a cyanobacteria. And that's definitely considered to be one line to explain the great filter. And so, but if we go and we see animals everywhere, and intelligent animals, and even pre-industrial civilizations, then we know that we're doomed. Because why do we see pre-industrial civilizations everywhere around the whole universe, and yet none of them have become advanced civilizations and spacecraft? Something is taking civilizations out the moment they develop advanced technology, and that would be waiting for us. So let's hope that we don't find any animals anywhere, and let's hope we don't find any pre-industrial civilizations, or even civilizations at our level of advancement. That would be scary. Let's do this again. Adam says, can you recommend any good books that you've been reading recently? So I feel like I talk a lot about the books that I'm reading. So please, everybody in the chat, recommend some books to read. Most recently, what have I got that's handy? Just started this. It's a proof. This is one of the advantages of being a journalist, is they send me proofs. So it's a book about looking for alien life under the surface of the water. And so we've talked a lot about this with Europa, etc. I don't know when this comes out. I'll let you know. But I am definitely enjoying it. April 7th. There you go. Let's see. Veronica Cure. So if the Earth slows down, will I weigh more or less? So if you're close to the equator and the Earth slows down, you will weigh more. And if the Earth speeds up, then you will weigh less. And eventually, if the Earth speeds up so much, it'll tear itself apart and you'll fly off into space, and then you'll be weightless. That's a good idea. So Nancy Graziano is saying that at the Weekly Space Hangout crew, they're working on a way to create and maintain a list of recommended books, fiction and nonfiction. I think that's a great idea. Donovan Gustafson, when will you get Ethan Siegel on your show again? The guy has the coolest mustache. Anytime. Ethan Siegel's always welcome. He's a treat. I've got a lot of other people that I do want to try and feature as well. You know, like my goal is to try, or one of my goals is just try and help as many other science communicators build their audiences and build awareness. So always let me know if there are creators, if there are science communicators, if there are astronomers, anyone who's willing to stand up and try to help share the science results, help engage with astronomy with the public. That I want to do everything that I can to help them to amplify their message. And that's one of my favorite things to do. It's why I have the guests here on this show. It's why we have guests on the Weekly Space Hangout. It's why we try and have other journalists on the Weekly Space Hangout. I'm trying to get as many people recognition for the work that they're doing in science communication as I can. You know, like right now, it's a very lopsided pyramid. And I'm sure you can imagine some of the names that are at the top of the pyramid. They get plenty of media play, but there's a lot of people that are working really hard who people don't know about. And I want to try and help flatten that pyramid a bit. Separate charge. Can we reproduce moon regolith on Earth in order to test construction or 3D printing of it? Absolutely. And in fact, Phil Metzger, who's going to be joining me here on the show in a couple of weeks, that's one of the things that he does, is creates lunar simulant, lunar regolith simulant and I think you can even buy it. So you can buy simulated Mars dust that you can run experiments on to try and figure out if your rover is going to be able to crawl through it, or if you're able to extract metal from it using your various techniques. We got about another 5 minutes left. Let's see. Apologies. So Bill Alexney, if light is affected by gravity, wouldn't the sun's gravity slow it down as it leaves, making those photons slower than just shy of 300,000 meters per second. So think about this question, because you literally just figured out time dilation, right? That for everything that we know of, if I'm on a car and I throw a rock off of the car, then the speed of the rock depends on like who's observing it. And so if I'm on the car and I throw the rock at 5 kilometers, I'm moving down the road at 100 kilometers an hour, and I throw the rock and the rock is going 30 kilometers an hour in the direction of the car, then to an outside observer, the rock is going 130 kilometers an hour. But from my perspective, it's only going 30 kilometers an hour. But from the perspective of when it comes to light, everyone sees light moving the same speed. I shoot the flashlight and I see the light move away at the speed of light. Someone standing at the side of the road sees the flashlight moving at the speed of light. I'm moving at different speed than the person who's standing at the side of the road. Therefore, we have to experience different amounts of time for that to be possible. And the same thing goes with gravity, which is that when you're in a heavier gravity well, think about the movie Interstellar, you experience different amounts of time than people who are in lower gravity wells to make everything make sense. And this, you can just imagine the thought process that Einstein was having as he was thinking about all of this weirdness, and the logical leap that he was willing to make was that the speed of light itself never changes, and that time is possible to be able to change. And that is, it's just this wonderful leap of imagination that I think is one of my favorite parts about just the whole idea of relativity. All right, we've got like 3 minutes left. Brian Yuko, if Carl Sagan asked Fraser for a list of Canadian sounds or music to include on the Golden Record, what would I say? Well, we need to have the Tragically Hip. We'd probably have a loon. A moose. I've never heard a moose, so. But I think that would be a Stellar's J, though. I've heard my share of those. But yeah, a loon for sure. That is a quintessential Canadian sound that we all have experienced. So. Apologies. We're about 2 minutes left. So let me see if I can just find one more. No, I think I'll wrap this up. So I got like one more minute. All right. So everybody has been posting tons and tons of great books into the chat again. So thank you. I hope the person who asked that question, you've now got a whole bunch of options to choose from. As I do read new books, I will share them with you. But so again, tomorrow at noon is going to be the premiere of our new episode about abort systems. And I was talking about this last week that I was afraid to set up these premieres because people always just gave me a hard time about them because they wanted the video now and they didn't want to wait. Well, someone disliked the video already. They haven't seen it and they disliked it. So now, I don't know what to do. I can't please everybody all the time, but we'll see. So hopefully you've signed up, and I hope that people enjoy the experience of watching the video with me, hanging out, chatting about and answering any additional questions. Or if we've made a horrible mistake, you can catch it while we watch it, and then I can pull the video down and we can fix it. So we do that. We got a question show coming up later on this week. Like I said, Friday's episode is probably going to be all about that amazing picture of the sun, which was taken by the new telescope on Haleakala, which I haven't said the name of the telescope because I don't want to get it wrong. So I'm going to practice the way to say it. Inouye? Daniel K. Inouye? Anyway, I'll practice that so I'll be able to say it properly during the episode. And then, of course, we've got a new episode of Astronomy Cast on Friday, new episode of the Weekly Space Hangout this week. So lots of good stuff. So we will see all of you tomorrow after the episode. Thanks, everybody. Oh, and thank you to all the moderators and everyone copying and pasting all the questions. That again, I could not do this without you guys. So thank you so much. All right, we'll see you later.